have a when you have horizontal lines and vertical lines, we all know that horizontal lines move left to right. It's not a secret. Vertical lines are all up and down. That hasn't changed. Now, we also know that every single horizontal line all starts with the exact same equation. Well, first I want to talk about slopes. The slope of every horizontal line is 0, and the slope of every vertical line is undefined. Okay? Undefined. Okay, what that means is this, is if you have a graph, and I think it's the easiest way to think of it, back this out. Bless you. Now, don't graph this, but what I want you to think of is if I took 1 divided by 2 minus x, what can't x be? Let me ask you this. Can you divide by 0? No, so what can't x be? 0. So this means that x cannot equal 2, because 2 minus 2 would give me a 0. Right? Now, what that occurs then, when you start to talk about graphs and equations and how everything works out, is that you get what's called an asymptote. Bless you. An asymptote is a dotted line of a boundary that you can get infinitely closer and closer and closer to, but you won't pass it. Okay? You won't get to it. It's like the old thing, I'm not touching you, I'm not touching you, I'm not touching you. You know, you can do that and everything, annoy your brother or sister, or your parents for all that matters, and go on from there and there. Okay? So, what happens a lot is that you say that it's an undefined value because you can't divide by 0. You get this asymptote. It's a line that exists that doesn't exist because you can't do it. Another easy way to think of it is if I took the value of 1 divided by x, 1 over x like that, my asymptote would be at, it would be at 0, correct? Because you can't divide by 0. Now think of it this way. If you took numbers, you know how you used to graph? You would just pick numbers and put them in a chart. If you took -2, -1, and I'm going to skip 0, 1, 2, you'd get -1/2, -1. So if I'm at -2, I'm at -1/2, -1. Watch what happens as you get closer to it. If I choose -1/2, you get 1 divided by -1/2. If you put that in your calculator, you're going to get -2. What's happening is that it gets infinitely closer and closer and closer to that value without hitting it. Same thing going the other way. It'll get infinitely closer and closer and closer to it without reaching it. If you take 1 divided by 1/100, it'll be 100, and so on and so on. So you get, with these boundary values, as you get closer and closer to 0, you're approaching this value that you can't reach. Because if you think of terms of, you've heard of the term infinity before? Yes. Infinite means you can add 1 number to it. You can always have a large number. It's the same thing as it moves closer to something. You can get infinitely closer to a value and never reach it. That's what happens with this asymptote. Because at 0, it doesn't exist. That's why it's undefined. It's kind of a long way of explaining it, but that's kind of the gist of it. Does that help? Does that make sense? I try to make it as like, so that's why we have undefined slopes. So back to this idea here, when we have horizontal and vertical lines, this is one of the shortcut things that we tend to show you guys, so that way it's easier when you see them later, is that just like that first question on number 37, It said, write the equation of a line that's parallel to a horizontal line. Well, remember, all horizontal lines have the equation y equals some number, whereas all vertical lines have the equation x equals some number. Then what's nice is that when you start talking about parallels and perpendiculars, all horizontal lines are parallel to each other. No matter what, every horizontal line is parallel to every other horizontal line. So you can say that all y equals a number is parallel to another y equals a number. Because those equations will always be parallel to each other. All right? Same thing with verticals. X equals a number will always be parallel to some other x equals a number. Because the slopes will always match. They're always going to be undefined. It's just going to go through different values. Think of your XY grids. All your XY grids all do that. Here's your vertical lines. They're never going to reach each other, and they're parallel. Here's your horizontal lines. They're never going to reach each other, and they're parallel. That's why this works. Which also means that horizontal lines are all perpendicular to vertical lines. And vertical lines are all perpendicular to horizontal lines. So you can flip-flop them around. So y equals a number is always perpendicular to x equals a number. And x equals a number is perpendicular to some other y equals a number. This will work all the time. So if you do happen to see a question like that, number 37, where it said write the equation of the line that is parallel to y equals 3 through the point 2, negative 5, you would recognize, oh, it's parallel to a y equals. Well, what's parallel to a y equals? Another y equals. And in that case, what did the y equal? And you go on from there. Okay? That's what this does. This little bit of information is something that students tend to always seem to overlook and always seem to overthink. All right? These should be the quickest ones. Just the quick little heads up. Does that make sense on that? Yeah. You look like you're about to say no. What's wrong? All right. So let's talk a little bit about graphing then. Why is graphing easy? How would you start graphing? You're right about 2 points with connecting the line, but let's say, what would you do if you had this? If I wanted to graph that. Okay. Shh. So, grab a couple sheets of this and not this for right now, please. Grab a couple of sheets of these. We'll use one for now and one for later. Yes, please. Grab a couple. All right. We're going to talk together. I mean, if you know what you're doing, that's fine. I just want to make sure I want to re-explain everything to everybody here. Today we're just working on graphing. All right, ladies and gentlemen. I know this very much. So what's happening when we start worrying about graphing is that we're going to default back to that y equals mx plus b. We try to use that method as much as possible because it's the easiest. Okay? We always want to try to get y by itself. So you have your y equals mx plus b, where b is your y-intercept and m is your slope. All right? Now, Josh, you just said that you would start where on this problem? Which one's the y? Is it the up and down or the left and down? The up and down. Remember, the y is the up and down, guys. Y is for the up and down. So I start at 4.
What's the graph?
Which way over? You pointed left. So here's the deal. -2 is your slope. Okay. -2 is the slope, and we all know that. That's not a big deal. But just like Josh said, it's actually -2 over 1. So when we're working with slopes and we're graphing slopes, our first step is always to go either up or down. Then our second step is always to go to the right. Since this is negative, your first step would be to go down. If it was positive, your first step would be to go up. Okay? So just like Josh was saying, you could go down 2 over 1. Down 2 over 1. Down 2 over 1. What's that? If it was -1, you'd go to the left. Now, what do you mean if it was like -2 over -1? If it was -2 over -1, what is -2 divided by -1? Positive. Yeah. Yeah, so you can go up to an order. And that's what I'm getting at, is that when you're thinking about these things, it's, and I remember when we did our slopes the other day, remember how you had a negative at the top, sometimes a negative at the bottom, depending upon how you use your calculator, you'd have to remember that the easiest thing to do is always to float that negative symbol. If there's just one of them, just put it in the numerator. That way you don't have to worry about it. That way we always go up if it's positive, down if it's negative, and always go to your right when you're done. Okay? That's a good question, though. Now, speaking of that, what's the opposite of down and right? Up and left. So what I like to do with a lot of these things, guys, is that I like to fill up my graph, just as many as I can throw in there, and then do your best. Yep. And that's how you graph. I know that all of you guys have graphed before. I know it's not a big deal, but it's just a matter of trying to remind yourselves of how to do so. Okay? Let's try another one. Excuse me. So I have y plus 3 equals -2/3 x. And I want to graph this. Oops. What do we have to do first, guys? Oops. I gotta get myself straight. Yeah, we're gonna get y by itself. So how do you get y by itself here? Yeah. So you subtract it over, so you're gonna get y equals -2/3 x minus 3. This is one of the things that happens a lot of times, is that they're not going to give you the graph of the y equals mx plus b straight in y equals mx plus b. They will tend to mess with you a little bit, and they'll put it in other formats. You just got to move things around. And it's not going to be very difficult. It's just one of those quick things. So in this graph, where would you start?
The bottom.
At the -3, yes. You start at -3. And then our slope is -2 over 3. So which direction are we moving again?
Yeah.
And then what direction? Left or right? Right. Yeah.
Mr. Murphy,
Yes, sir.
is that you only negative or just the fraction?
The fraction is negative, but what we do is we say that it's. I just have to explain this. Remember, when you have the -2 over 3, that just means go down and then go right. That's all that means. Fractions can be negative, and when fractions are negative, it's -2 over 3, which is the same thing as 2 over -3, which is the same thing as -2 over. All three of those values mean the same. When I usually do this, I'm always going to try and write them like that, because it's easier to remember. Okay. Take a minute. Graph those two, please. And graph those two, please. Now, what happens a lot of times with this stuff is that there's going to be many different ways to get about solving for y. If you wanted to, I think, Josh, you probably recognize that there's what we call a GCF, greatest common factor. Everybody notice that they're all divisible by 2? One of the things you could have done right away is divide everything by 2. That's one of the methods. Okay. If you divide everything by 2, you get 2x plus y is 4. You still have to get y by itself, don't you? How would you move the 2x? You would subtract it to get y equals negative 2x plus 4. That's one method. Okay? Absolutely. That's the other thing. Yes, ma'am? Yeah, they're always around. We use them in things like this. It's not like I'm going to give you homework out of here. Find the JCF. Because in this case here, the other method that you can do it, I think, is this what you did in response? You just subtracted 4x right away? You got 2y equals negative 4x plus 8. And then what did you do? Then you divide by 2. That's fine. The only thing is, just you have to remember, guys, when you're dividing, you got to make sure you divide everything by 2. You get the exact same thing. Y equals negative 2x plus 4. Okay. There's a couple of different ways to go about doing that. That's one of the methods. So if you got that, then, actually, did we just do the first example as negative 2x plus 4? Yeah. Hey, look at that. Hope that graph looks the same. Yes, exactly. All right, what do you do with the other one on 30? Which one is it? Minus 4 or add 4? You're going to add the 4 to the other side. You're going to get y equals x plus 3. Slope is 1. Very good. So my equation is y equals x plus 3. Aren't all lines straight? It's not a vertical line. It's not a horizontal line. It has a slope of 1, so it starts at 3, up 1 over 1, right? Very good. Madam. Or down and left means the same thing. And you get stuff like that. Again, it's not going to be horribly, horribly scary, bad, difficult. It's just procedural. Okay? It's a lot of procedure here.